In this lecture, presented by www.free-academy.com, we're going to be covering the derivatives quotient rule. The quotient rule is incredibly powerful because it allows us to find the derivative when we have one function divided by another function. The quotient rule, as it states, the derivative of f of x divided by g of x is equal to g of x times f prime of x minus f of x times g prime of x, all divided by g of x squared. Now that's g of x, all of g of x squared, not g of x squared. So the biggest problem that I find that students have with the quotient rule is not actually solving any of the problems, it's remembering the stupid formula. And I have an interesting little song that I've used. Well, I wouldn't call it interesting, but I have a song that I've used since I was in introductory calculus. I'm going to teach you guys now. The derivative with respect to x of f divided by g. Notice we use this notation a lot. F equals f of x and g equals g of x. So just be familiar with that. Call f is equal to high because it's on top, g is equal to low because it's on the bottom. And then I'm going to use d as equal to the derivative. So the derivative of f divided by g is equal to low d high minus high d low over low squared. Low d high minus high d low over low squared. And then if you actually put in the values of that, you get low g of x, or we can just write g, times the derivative of f, the derivative of high, minus f times the derivative of the bottom over the bottom squared. This is g. Low d high minus high d low over low squared. Now, I'm not going to get my feelings hurt if you decide not to use it, but that was just something that I wanted to tell you guys to help you remember it. Let's get in and let's do some actual problems. Let's find the derivative with respect to x of sine of x divided by x squared. In this particular situation, we will assign f of x to equal sine of x, and g of x will equal x squared. Now notice I said we assign f of x and g of x. We could have called the top a of x, the bottom b of x, or the top g of x and the bottom z of x. It doesn't matter as long as we're self-consistent with our formula here. Whatever function you use as the bottom goes, where you have g in the formula. Whatever function you use on the top goes where you have f in the formula. But anyways, we don't have all the pieces we need. We still need f prime of x, and we still need g prime of x. The derivative of sine of x is equal to cosine of x, so that's easy. And the derivative of g of x, which is x squared, is equal to 2x, so that's easy as well. So now it's just a matter of plugging everything into our formula. We have low d high minus high d low over low squared. And we can simplify all this. I'm going to factor in x out. We'll get x cosine of x minus 2 sine of x over x to the third. And you can see, if you work out the algebra, that that is correct. Now, we can do this problem a completely different way. We change here to yellow. Let's say that this is also equal to 1 over x squared times sine of x. Which it is. That's exactly the same. In this case, we can use the product rule. Say f of x is equal to x to the negative 2, and g of x is equal to sine of x. We find f prime of x is equal to negative 2 x to the negative third, and g of x is g prime of x is equal to the cosine of x. So now we can plug that into our product rule, and let me rewrite it here. D by dx of f of g is equal to f prime g plus g prime f. So this will all equal f prime negative 2 x to the negative 3 times sine of x. This is plus x to the negative 2 times g prime of x, which is cosine of x. Now I'm going to just erase a little bit of room here. And I'm going to show you that these two are exactly the same. First, let me take this formula right here, and I'm going to divide through the denominator. So this will be equal to x times the cosine of x divided by x to the third minus 2 sine of x divided by x to the third. We have an extra x here, so this is equal to cosine of x divided by x squared minus 2 sine of x divided by x to the third. Now if we take this equation, we have negative 2 times the sine of x. We take the negative 3, change the sign, put it to the bottom, we get x to the third. And this is going to be plus cosine of x divided by x squared. So we've demonstrated that these two formulas are equal. And this should be expected. If you're taking the derivative of the function, whatever formula you use should give you the same derivative on the outside. They might come in different forms, they might look a little bit differently, but mathematically they're always going to be exactly the same. So that's the quotient rule. I showed you it's consistent with the product rule, and in the following lectures we're going to be doing lots and lots of practice with these. So check out the practice problems, get good with these.